Hello and welcome back to another episode of Math with Stone. Today we're going to be talking about independent and dependent events, and we are going to also talk about how to use some of these formulas that you may have seen, which often confuse people. All right, so let's start with the independent and dependent event. It is an independent event if one outcome does not influence the other one at all. So if you flip a coin and then roll a fair dice, is it possible for the coin to land on heads and influence that dice at all? And the answer is no. If it cannot influence the other one, it is known as independent. Okay? If one would influence the other, then it would be considered dependent. Okay? So here, if we have a box of chocolates that contain 5 milk chocolates, 5 dark chocolates, and 5 white chocolates, you randomly select and eat 3 chocolates. The first piece is milk chocolate, the second piece would be dark chocolate, and the third piece is white chocolate. Well, if you've taken a chocolate and you've eaten it, that means there is less of that chocolate. So if you took a milk chocolate out of your box of chocolates, the likelihood of you getting a milk chocolate again would be a little bit lower, because what if you had only 1 milk chocolate? The likelihood of you getting again is 0. Okay, so these are dependent events. The fact that you got a milk chocolate makes the dark chocolate probability go up because you have now a higher ratio of dark chocolate. So these would be considered dependent events. Spelling is not my strong suit. Finding the probability. You flip a coin. This is conditional probability, and we did a whole video on it, but I'll do a warm-up real quick. You flip a coin and then roll a fair dice, 6-sided dice. The coin lands heads up, and the dice shows an even number. What is the probability of each of those occurring? If it is independent events, which these are, then you just multiply them. So the idea of it being heads or tails, heads would be 1 over 2, 1 out of half of the time. And the even numbers would also be 1/2 of the time on a dice. So you multiply them, you get 1 out of 4. All right? Versus number 7, which we're also going to have a whole video on this because this is a very complicated one. There are 8 shirts in your closet. 4 are blue and 4 are green. So if you randomly select to wear a shirt on Monday, good job for wearing clothes. And then wear a different shirt on Tuesday, good job for wearing clean clothes. You wear a blue shirt both days. So how many of them are blue? 4 are blue out of the 8. But then the next day, you're wearing a different blue shirt because it's hopefully clean. And you would now have 3 shirts that are blue because you wore one of them, and 7 shirts left in your closet because one of them's dirty and probably on your floor. So you multiply those, you get 12 out of 56. Assuming 7 times 8 is 56. I always struggle with 7 times 8. Anybody else struggle with 7 times 8? It's 56. It does simplify. Sometimes I leave these in their unadulterated, unsimplified version to let you kind of know where it came from. All right. The next part, determining if events are independent based off of stuff. So here, if and only if you multiply A times B and it equals A and B, then they will be independent. So is 2 out of 5 times 1 out of 5 equal to 2 out of 25? And the answer to that is yes, and therefore they are independent because when you multiply them, that made it true. Versus over here, 2 out of 5 times 1 out of 4, 2 out of 5 times 1 out of 4 is not equal to 1 out of 25. Therefore, these would be considered not independent or dependent. Apparently, I can't spell dependent. Okay? For the next few ones, we are going to have to utilize a formula. Now, these formulas can be used in a variety of word problems, but I find that sometimes it just makes it more confusing. Okay? So, if we have probability of B given A, that's what that bar means. So this could be used for conditional probability. Then it will be the probability of A and B multiplied together, divided by the probability of A. Whatever letter this is going to be on the bottom. So probability of A and B divided by probability of A. So we are just going to fill those into our formula. We are looking for B given A. So we would have to do 1/4 times 3 out of 5, because that is what A times B is, A times B, divided by the probability of A, which is 1/4. Now, if you're looking for the given part, something should cancel out because it would be really silly to multiply these and then divide because they would just go away, leaving you with 3/5, and also leaving you with this feeling of it can't possibly be that easy, can it? And sometimes it is. Sometimes it's not, but sometimes it is. All right, here we got 9/12. We're given the probability of A given B. So see how here it's a B here? It looks like it's A divided by B. It's not, but if it is, if you think of it from that perspective, here we had divided by A. On our formula, we have to divide by A. Here we have divided by B. It's not, it's given B. But we will end up using the formula where it would be B on the bottom. Okay? So we have 1/5 for this part. And then A times B. I don't know what A is, so I'm going to write A times 9/20. But then I have to divide by 9/20. Okay? Again, things cancel. 1/5 is equal to A. Okay? So these aren't that bad. It will get a little more difficult, maybe if you're not careful, with the A and B part, but again, these events are independent. This only works if they are independent events. If they are conditional events or not dependent events, then it will not work. So here, finding the probability of A and B is as simple as doing 3 out of 10 times 13 out of 20, which gives you 39 out of 200. A and B is A times B. See if they get anything harder. Maybe this one's harder. It's in a slightly different section. Let's see. Probability of A given B. I'm going to look for one hard one. Here we go. Got a hard one. Hard one to finish it off. Probability of A given B. I have no idea why I turned that around. We will need that formula. Probability of not A is the same as saying probability of B. That's just a fancy way of saying probability of B. Because if it's not A, it's B. But not necessarily. I take it back. What if there's an event C or something like that? So I take it back. Probability of not A is 3 out of 5, which means the probability of A is really 2 out of 5 because if not A occurring happens 3 out of 5 times, probability of A occurring would happen 2 out of 5 times. So let's fill it in the formula. We got probability of A and B given to us. So this is going to be 6 out of 25 on the top. They already multiplied it for us. The harder part here was figuring out the probability of A was 2 out of 5. So we would have to put 2 out of 5 on the bottom here. Because they've already multiplied these, we can't just cancel. But you can type it in your calculator like that if you would like to find the probability of B given A. But you are also able to take this, whatever you're dividing by, and flip and multiply. So if we flip and multiply, 6 divided by 2 makes 3, and 5/25 makes 1/5. So this is going to kind of simplify to a 1/5, and this is going to kind of simplify to a 3. So we end up with a final answer of 3/5 because 5/25 is 1/5, and 6/2 is 3. 3/5, final answer. That's going to do it for this one. I will see y'all in the next one. See you later. Bye.